Hello viewers, welcome back to my channel Shraddha's Physics. In this part we will see the equation of motion and the fast integrals of motion. So let us start with the central force and the motion in a plane. If a force acts on a particle in such a way that it is always directed towards or away from a fixed center and its magnitude depends only on the distance from the center, then that force is called the central force. That is, let us consider a particle is present at this point, that is on the circumference of the circle. When a force is acted on this particle, suppose this particle is P, so that the direction of the force is towards the center of the circle, then that force is called the attractive force. Or when the force is away from the center, then that is called the repulsive force. And here this type of force is called the central force. That is, it only in case of the central force means it only depends on the distance r. Okay, it only depends on the distance r. That is, if we will consider for the polar coordinate system, that is when you convert the Cartesian coordinate system in the two dimension, that is xy coordinate can be converted to the r theta coordinate, that is a polar coordinate. But here when the force only depend on the coordinate r only, then that is called the central force motion. So the central force can be represented by, suppose if I will write capital F, then this capital F will be equal to small f of r into r cap, and here this r cap equal to r vector divided by the magnitude of r. That is the central force notation. Okay, here the f of r, it represents the function of the distance r only, and this r cap vector, that is r cap equal to r vector divided by the magnitude of r, and that is equal to the unit vector along the r vector from the fixed center. That is, the center is fixed here. And when f of r is less than 0, that is the force is attractive in nature. That is when this force is negative. F of r is less than 0 means when the force is negative, then the force is attractive, and when f of r is greater than 0, that is your positive, then that force is repulsive in nature. And you should note that a central force, it always a conservative force. If V of r represents the potential energy, then we can write the central force equal to the negative gradient, that is minus dou V by dou r, negative gradient of the potential. Okay, or this capital F, you know, F equal to f of r into r cap. This is your total F, central force F equal to f of r into r cap. So in place of small f r, so you can write this is your minus dou V by dou r, and you know r cap equal to r vector by r magnitude. Okay, so the potential energy for the central force, it depends only on the distance r. So the system possesses the spherical symmetry. Now if I will consider for the torque that is acting on that particle, then we can write tau will be equal to, this is your tau, that is equal to r cross f, and here this f vector equal to f of r into r cap, or this r cap equal to r vector divided by magnitude of r. But here this r vector cross r vector, that will goes to 0. Okay, that will goes to 0, that is torque goes to 0. When torque equal to 0, we can write torque equal to the rate of change of angular momentum, that is dl by dt goes to 0. When dl by dt is 0, so we can say that L equal to constant, that is the angular momentum is conserved. When L equal to constant, so it means that angular momentum is constant. That is, in case of the central force motion, the angular momentum is conserved. Or we can write L equal to r cross p equal to constant, that is here it is a constant vector. So the motion of the particle under the central force, it takes place in a plane. That is, L vector is perpendicular to the plane containing r and p. That is, here the p represents the linear momentum. Now we will see the equation of motion under the central force and the fast integrals. So let us consider a particle of mass m. It is moving under the central force F about a fixed center, that is O. Okay, now if we will calculate the kinetic energy of the particle, so in the Cartesian coordinate system we can write kinetic energy equal to 1 by 2m x dot square plus y dot square. So here x dot represents the vx, that is the velocity of the x component, because you know vx equal to dx by dt, or this dx by dt can be written as x dot, and similarly vy equal to dy by dt, or it can be written as y dot. So here this is half mv square is written in terms of half m x dot square plus y dot square. Okay, now you see that is also equal to, if I will split, so let us see here, suppose this is the path of the particle and here the mass of the particle m is present at this point. Okay, so from the origin the distance of the particle is suppose r, and it makes an angle theta with the x coordinate. So here if I draw a perpendicular, this is your x, and if I draw a perpendicular on the y axis, this is your y distance. So here we can write x equal to r cos theta and y equal to r sin theta. So you can calculate, okay, cos theta equal to your b by h and sin theta equal to p by h. So from that relation you can calculate. Since x equal to r cos theta, you can calculate x dot, that is dx by dt equal to r dot cos theta minus, if I will take cos theta derivative, then this will be minus sin theta, theta dot, and r is your constant. And similarly y dot will be equal to this r sin theta becomes r dot sin theta plus r sin theta derivative will be cos theta into theta dot. Okay, now here if I will substitute this value here, so this x dot square will be equal to, x dot square means this total square, if I will take x dot square means this total term square, and for y dot square I have to consider this total term square. So this t equal to half m for the x dot square, this much, for y dot square this much. Now if I will put a plus b whole square form, then this will be 1 by 2 m is taken constant. So this minus r sin theta, theta dot square will be r square sin square theta, theta dot square, plus this will be r dot square cos square theta, and this minus 2ab, because this is in the form of a minus b. So this will be minus 2 r dot sin theta cos theta, theta dot. Okay, and similarly for r cos theta, theta dot plus r dot sin theta whole square, then this will be equal to r square cos square theta, theta dot square plus r dot square sin square theta. Okay, and here 2ab, so 2r into r dot into cos theta sin theta into theta dot. Now here you can see these two terms get cancelled, one is plus and having another one is a negative sign. And also if we will take common from this term and from this term, that is r square theta dot square, if we will take common, then this will be sin square theta plus cos square theta equal to 1, and r dot square if we will take common, then this will be cos square theta plus sin square theta equal to 1. So after taking common you will get t equal to 1 by 2m r square theta dot square plus r dot square. This is the total kinetic energy of the system. Similarly, the potential energy, we know this is the function of r only. Okay, it only depends on the distance r. So we can write v equal to v of r. Now the Lagrangian equation or the Lagrangian for the particle, first of all we can write L equal to t minus v, and in place of t we can write this is 1 by 2m r square, sorry, r dot square plus r square theta dot square, this term, minus this is your v of r. So after substituting all this value, we will get L equal to this much, that is the Lagrangian. Now we will calculate for the Lagrangian equation of motion. So to calculate the Lagrangian equation of motion, you can see here the Lagrangian, it is the function of you can see r theta, r dot, theta dot and t. Okay, so now from this expression you can see, since it is the function of r dot and t, so we have one equation with respect to the r coordinate, and we have also another Lagrangian equation of motion for this theta coordinate, that is theta, theta dot and t. Now first of all we will calculate for the, let us calculate dou L by dou theta, dou L by dou theta dot, because you know the Lagrangian equation of motion for the theta coordinate you can write d by dt, sorry, d by dt dou L by dou theta dot minus dou L by dou theta equal to 0. And similarly for the r component you will write d by dt of dou L by dou r dot minus dou L by dou r equal to 0. So here you have to calculate for dou L by dou r and dou L by dou r dot, and also you have to calculate dou L by dou theta and dou L by dou theta dot. So let us first calculate that, after we will substitute the value. So here you can see dou L by dou theta, because this Lagrangian doesn't contain any terms of theta, so that value goes to 0. And dou L by dou theta dot will be equal to, this will be 1 by 2m r square theta dot square derivative. So this 2 get cancelled, that will be mr square theta dot. Again for dou L by dou r, this term contain the r, so this will be 2 get cancelled, that is mr theta dot square. And again this v of r also contain the term r, so that will be dou v by dou r. And again, so dou L by dou r dot, for r dot term, that will be 2 into 1 by 2 mr dot. So this 2 get cancelled, that will be mr dot. Now if I substitute this value, so let us first substitute for the theta value. That is for theta, if I will calculate the Lagrangian equation of motion is this much. So dou L by dou theta is 0. We will only substitute mr square theta dot. So d by dt of mr square theta dot equal to 0. Or you know, the angular momentum can be written as r cross p. So this, in place of r cross p, you know p equal to mv, that is the linear momentum. So that will be mv here. Or v equal to r omega, we can write v equal to r omega, that will be mr square omega. Again omega can be written as d theta by dt, so that will be mr square theta dot. You can write this as your small l, so that you will not confuse with the Lagrangian and the angular momentum. So here mr square theta dot. So here d by dt of mr square theta dot equal to 0, or that mr square theta dot will be constant, because the derivative of this term equal to 0 means this term is your constant. But this mr square theta dot is nothing but the angular momentum. So here we can consider this L equal to constant. This is called the fast integral of motion. That is, if we will use the Lagrangian equation of motion, so you will find the angular momentum is constant in nature. So what is the physical interpretation of this equation? So here, since m is the constant, we can write this d by dt of, in place of mr square theta dot, we can write 1 by 2 r square theta dot equal to 0. Or 1 by 2 r square theta dot is the constant, and that is known as the areal velocity. Areal velocity means the area swept by the radius vector per unit time. And now if I will write this dA equal to 1 by 2 r into r d theta, that is, you can see in this figure. So here this is your path where the particle is traveling. So here it changes the position from p to p prime, suppose. So here this path is your dA. So during its motion, the angle made by the particle is d theta, and the radius, you know, that is your r. So that this distance will be r d theta. So here in this expression you can write, if I let dA by dt, also here I have to divide dt term. So this will be dA by dt equal to 1 by 2 r square d theta by dt, or d theta by dt can be written as theta dot, and that is called the areal velocity. So it means that the radius vector, it sweeps out equal areas in equal interval of time. That is, the areal velocity is constant. This is the physical interpretation of this. When this angular momentum is constant, it means that here the areal velocity is constant, that is, it sweeps equal areas in equal interval of time. Or we can say that the conservation of angular momentum, it is equivalent to say that the areal velocity is constant. So here simply we have calculated the Lagrangian equation for the theta. Now we will see for the Lagrangian equation for the r value. So here the Lagrangian equation of motion is this much. If I substitute that value dou L by dou r and dou L by dou r dot, so you can see from this equation 5, we have already calculated this value dou L by dou r and dou L by dou r dot. So after substituting this value, we will get this much. Simply we have substituted the value, that is the dou L by dou R equal to this much and dou L by dou R dot equal to mr dot. Okay, so here d by dt of mr dot will be mr double dot minus this will be mr theta dot square, and that is equal to this minus minus becomes plus, and when I will take this term to the right hand side, then this will be minus dou v by dou R. So here this is minus dou v by dou R, and again you know this L equal to mr square theta dot, or this theta dot can be written as L by mr square. Okay, so L is here the angular momentum. So if I will replace this theta dot in terms of L by mr square, then this term will be equal to this much. Okay, or this can be written as mr double dot equal to this mr and 1 mr get cancelled, so the remaining term will be L square divided by mr cube. Since it is minus sign, if I'll take to the right hand side, then it becomes the positive minus dou v by dou R. Again, if I will take common minus d by dr, then v will present here. The first term is your v, because minus dv by dr equal to this much. Now for the second term I can write this is your L square by 2mr square derivative, because if we will take minus d by dr of L square by 2mr square, because L square by 2m is constant, so this will be r power minus 2, that is minus 2 divided by r cube. This minus minus get cancelled, then finally that 2 get cancelled, that will be L square by mr cube. So that is minus d by dr of L square by 2mr square, its value is equal, that is this much value is equal to L square by mr cube. Okay, or if I will multiply this r dot throughout the equation, then this will be mr double dot into r dot equal to minus d by dr v plus L square by 2mr square into dr by dt, because you know r dot equal to dr by dt. We have multiplied r dot in the left hand side as well as the right hand side. This r dot is nothing but dr by dt. Okay, again this mr double dot into r dot can be written as d by dt of 1 by 2 mr dot square, because if we will take the derivative with respect to t, then this will be 2 into 1 by 2 mr dot into r double dot. The 2 get cancelled, so we will get this much, that is m r double dot into r dot, that is equal to, if I take common minus d by dt, then this will be v plus L square by 2mr square. You can consider this dr get cancelled, so that is simply minus d by dt of this much. Okay, or if I will take this term to the left hand side, then this will be, and also we have taken common d by dt term here, so that is 1 by 2 mr dot square plus L square by 2 mr square plus v, that is equal to 0. Here this L represents the angular momentum, this small l. Okay, and that is equal to this bracketed term now goes to the constant. So this term equal to constant, because d by dt of some term equal to 0 means this bracketed term is your constant, and that is the total energy of the system, that is 1 by 2 mr dot square plus L square by 2 mr square plus v, that is equal to the total energy. And this is the another fast integral of motion, and it leads to the conservation of energy, that is from the central force of motion we have concluded there are two integrals of motion, that is the fast integral of motion we may say. One leads to the conservation of angular momentum and another one is the conservation of the energy. And again you can see here in this expression you can write also 1 by 2 mr dot square. In place of L, that is the angular momentum, we can write mr square into theta dot square, that is mr square theta dot whole square divided by 2 mr square plus v, that is also constant. Simply we have substituted the value of L equal to mr square theta dot. Okay, so here it is L square, it is your L square by 2 mr square, so this total term square, and again this can be written as 1 by 2 mr dot square, this m square with m get cancelled, that is 1 by 2 m r square, so 1 r square get cancelled with 1 r square, so 1 by 2 mr square theta dot square plus v equal to E, that is the total energy. Or if I will take common 1 by 2 m then this will be r dot square plus r square theta dot square plus v equal to E. And also we know the kinetic energy term here we have calculated, that is equal to 1 by 2m r square theta dot square plus r dot square. So here we can write this total value, this total term is your T plus V, that is equal to E, that is the total energy of the system is also constant. So in this way we can calculate for the central force of motion. So there are two fast integral of motion. One is mr square theta dot, that is L equal to constant, this is the angular momentum equal to constant, and another one is 1 by 2 mr dot square plus L square by 2 mr square plus V equal to total energy of the system, that is also constant. Okay, so this is all for today. Thank you.